I'm Lori Meggs.
And I'm Bill Hubscher. Welcome to Focus on Marshall. On today's program, we're going to show you a lab here at Marshall that can take this and build this.
But first, let's go for a ride on the space shuttle. Take a look at this.
Good copy. And we are about 45 seconds to hand over to Z.
These are some of the exciting new images of the space shuttle during launch. We're here now in the Imaging System Lab with Eric Corder, who's been instrumental in developing some of those systems. Eric, tell me what you do in this lab.
Well, during the last 3 years, our primary focus has been on developing requirements and a design to look at the shuttle overall vehicle during flight. One of the primary designs that we worked on is the external tank camera, which you've had views of that everyone has seen. And with the next upcoming flight, we have 2 SRB cameras on each solid booster, so we'll have a total of 5 cameras viewing the shuttle during flight. Our primary focus is to look at the overall health of the vehicle. In particular, we're looking at the wing leading edges, and we're also looking at the bipod region.
Well, do you have any hardware you can show us?
Yes, we do. We have an external tank camera that we can look at, and we have models of the solid rocket booster camera that we can view as well.
All right, let's take a look.
Okay.
We're joined now by Jeremy Meyers, who has a table full of hardware he's going to show us. But we're going to start with the camera that was instrumental in the return to flight effort. Right, Jeremy?
That's right. This camera here is an example of the camera which flew on STS-114. And this unit here was actually what caught the debris and was used by the video analyst to understand what happened post-flight. We as a group here have worked with Lockheed Martin in developing what the requirements needed to be. Also, we worked with EV-12 and determined what the field of view would be. They can do modeling within that group. So by working as a team through all these organizations, we were able to have a system which actually ended up being Imaging Solution of the Year in 2006.
Now, you've got a couple of other newer cameras here that are going to fly on the next shuttle launch as well, right?
That's right. During the next flight, we're going to have cameras on the SRB, and we've been working with USA to develop those same requirements to model field of view with EV-12 and going through that same process. And we're going to have a camera that's going to be on the aft of the SRB as well as the forward of the SRB looking at the shuttle.
And what about the housing for this one?
Well, of course, we have to rehouse these to harden them, and there's a process that's gone through that to withstand the thermal environments because these are on the outside of the vehicle.
Now, you're also working on cameras for the next generation of space vehicles. What do we have over here?
Well, we're also looking at developing requirements and looking at various camera systems which will be able to fly on the next vehicle.
Looks like you have a really small one there, too.
That's right. This is an example of a small camera that might have a possible solution. There's also higher resolution cameras, so there's all kinds of things you have to consider as far as requirements, what's the best solution, what will fulfill the needs for NASA in the future.
And you can get that one in very hard-to-reach places.
That's right.
And what about these 2 cameras you have mounted here?
Well, another possibility is to develop a stereo pair, and that allows you to measure accurately where something that you see is in space. Also, we have GPS systems, which allows us to add timing, and that allows you to look at different cameras and to link up what you're looking at the same time.
And you also have this black box to move from videotape to pure digital recording.
Right. This is an example of another project that the group here is working on, and this flies on a sounding rocket, but this is a video recorder, and it's a digital video recorder, so basically you could have camera systems coming in and recording that real time.
Jeremy, thanks very much. Let's head back over to Eric and Lori.
We're back here with Eric in the Image Characterization Lab, and this is where you actually look at the performance of the camera.
That's correct. We take the camera that we've designed and we bring it in here and we look at the things like lens distortion and signal noise ratio. And from that data, we utilize that to look at the shuttle data that we get back from the external tank camera, for instance, and we can determine size of objects that are in the field of view. And that gives us a nice end-to-end system.
All right, well, we can't wait to see the next images that are on the next shuttle flight. Thanks for being with us today.
Well, thank you.